Today I'm working on the V12 build again. This is my home built V12 supercar that I'm making. Today I'm figuring out how the manual gearbox is going to attach to the M120 V12, the original Zonda engine. So let's dive in. First I need to remove this gearbox. This is an Audi 01E. It's one of the strongest versions of the Audi Porsche transaxles. So this is going to be perfect for this build. The only weak point on these is the synchro meshers, but I'm going to rebuild this to allow it to handle even more torque. That's the gearbox out the car. Now I can put it up on the workbench. Now I can start having a look at what I need to do. So there's two main things I need to do to attach this gearbox to that engine. I need to first join the outer casing of the gearbox onto the engine. So that needs bolting on somehow. That's going to need some kind of adapter. And secondly, I'm going to need to join the two shafts together. So the gearbox shaft to the crankshaft. So they're the two challenges. I'm not going to be making the final parts. It's just the first time figuring this stuff out. I will be doing some fabrication in this episode though, so stick around for that later. The few bits that I want to do on this thing. I want to get some rough measurements of how big these parts need to be. Then I can order some sheets of metal at the right thicknesses and start machining these parts myself to make the adapter and whatever adapt plate needs making for this. So this is the clutch that I've got, just to test the dimensions. This is a stock clutch. I'll probably be upgrading this to either a paddle clutch or maybe a double clutch, but it'll be the same dimensions. So the goal here is to check the stack height of the clutch and measure how far in it's going to go inside this gearbox. I believe it's going to stick out slightly, so I need to make sure there's enough room on the engine side for the clutch to sit, and if there's any gap in between this and the engine, I need to fill that with an adapter plate. So the clutch attaches to the gearbox using these splines here. They're a little bit rusty, so I need to clean them up before I put this on. I bought this separate from this, so I need to make sure it all works and all fits. So the next thing I'm going to do is I'm going to strip the clutch down just to take this inner clutch plate out. This will allow me to slide the clutch on without getting it stuck inside the gearbox, and we can have a look at the flywheel, see what he's doing there to modify it to attach it to that crankshaft. If you're enjoying this, give me a quick thumbs up. It takes a lot of hard work making these videos. I've also now got memberships where you can see my private projects as well as behind the scenes on the build. I've got loads more builds planned. If things go in the right direction with the channel, then you're going to see a lot more crazy things. So this top part is a spring plate for the clutch. This is what keeps the clutch together and applies the pressure to actually let you drive the car. When you press on the clutch in the car, the pedal ends up pressing this piece down through hydraulics or sometimes a cable, but the whole purpose of pressing the pedal is just to depress this spring. And when you depress this spring, it takes the pressure off the clutch plate inside, and that allows the clutch to slip. So there we go. This is the spring plate. So as these springs get pressed down, this moves inwards to take the pressure off the clutch. So this is what actually couples the clutch mechanically. So inside that, we've got the actual clutch plate. That's the friction material. And on the other side, we've got another surface where this will grab on. So the clutch essentially works exactly the same as like a brake disc in a car, where you've got the pads clamping onto a surface, except this time the friction material is the actual disc and the steel material is these two faces. So this is the stock clutch. It's going to get me started at first. It's still got loads of meat on it, it's got loads of life left on it. It's just this might not take the full torque of the V12. If I drive it carefully, I'm sure it will, I'm sure it'll be fine. But ideally I want to get an uprated clutch. On the back side, you can see we've got an 8-bolt pattern. That's the same as the Mercedes engine, where we've still got 8 bolts. They are slightly different spacing though, so I'm going to have to do some machining on this to make it fit, and either make an adapter plate or modify this to make it all work. Now that I've got the clutch removed, I can put this back on there Now I can test fit this whole assembly without the clutch fitted. It will be slightly different dimensions, but without the clutch, these springs are going to be further out. This is the widest that the stack's ever going to be. With a new clutch, it's going to be even skinnier. So I need to plan for the widest it's ever going to be. So as I drive, this thing doesn't seize inside the gearbox or the engine. So that's as far in as I can push it. So now I'm going to take this clutch back apart, measure how thick this is currently simulating, measure the thickness of my clutch plate I've currently got, which is a good clutch plate, put it back in, slide this whole thing back on, and then this thing will sit nice and square. I can get accurate measurements of how thick my plate needs to be. So I've done a lot of working out off camera, loads of measurements, and I've come up with my final numbers for the adapter plate, which I'm going to do 18mm in aluminium with helicoil steel threads to make it even stronger, and then the center chunk that converts this flywheel onto that crank is going to be 45.8mm. This took a long time. If you want to see how I came to these numbers, have a look at the members video. I've also designed the crank adapter for exactly how I'm going to do that. I've just done a quick sketch. I'm going to convert all this into CAD and 3D model all the parts that I need to make. The adapter for this is going to be a big solid piece of steel, so it can take all that torque. I'm going to stack the bolts to make sure I don't use really long bolts and they don't twist under the engine's torque. So I'm going to have the original bolts that came with this flywheel, bolting it on to the adapter, and then a second bolt that bolts into the engine. I won't be using these bolts, these are just for testing. Now we can get on with some of the other jobs. I want to do some fabricating on this gearbox to start figuring out how I'm going to mount this in the car. So I've only got these 4 points to work with on each side. You can see they're all offset really weird, and they're also offset this way, making it even harder. I'm going to use them to bolt this thing into the car. I'm going to have tubes on each side that extend over here, and then I'm going to have some pieces extending off that, attaching onto the gearbox plates. So these tubes here are actually telescopic, so they fit inside the chassis rail. I'm going to put some pinch bolts through there. This is so if the rear of the car ever gets bumped, it doesn't destroy the chassis and write the chassis off. It only slides these extension rails in and destroys the subframe. I don't want to put all this work into building this thing and then it get damaged and classed as unrepairable. I can just replace the rear subframe and repair that stuff. The car's still good to go. So the first step I'm going to do here is I need to design some kind of plate that's going to support all these points and cut it out of cardboard so I can really plan how it's going to be. Then we can transfer that over to steel and make some actual mounts. I do have the original mounts that came with this gearbox, but as you can see, there's such a weird shape. It's not something I can really use. These would bolt on like this, but then they've not really got a good area for me to attach it into the car. Because if I wanted to use these, they're just going to be quite bulky and they're not going to attach onto that tube very well. It's going to make it quite difficult to do. It's going to be easier if I start off with my own plate, then I can design whatever I need. But I can use these as a good reference point. We can measure these or put cardboard up against them. I can use that to transfer the holes. And the goal here is just to get a nice plate that's going to fit down the side of all these and collect all these points together. Then I'll probably have some tube work that's going to attach onto these things. First, I'm going to start with this one, which is a bit more flat. I'm using a piece of paper to transfer the holes over and make my template. So this works best when you've got a little bit of dirt on your hands. You can just rub all the points that you need to transfer. This is really handy when you want to just get hole patterns transferred onto pieces of plate. So we can even do the outline. As long as I'm careful not to move this thing, I can even get the outline transferred onto this piece of paper. This will give us a good starting point for exactly what I need to do. There we go. That's that same shape, just transferred onto the paper. Now cut this out and then we can make this in steel. Now I can cut these holes out. So there's my template with all the holes cut. Now I can double check it fits on this and my gearbox. So there we can see all the holes are lining up nicely. So this fits on here just like that. So we can see the holes are all lining up nicely. There is this area here that I need to plan for because that's sticking out past these faces. So I need to do a cutout in this plate to match that. Looking like I need to cut along there and along here. Okay, now I can try again. So that's looking a lot better. Everything's lining up. This is sitting nice and flat. So it looks like it's going to work well. No clearance issues. Now I've chopped this portion out. So that's going to be a good area for me to put a tube up to and weld it onto once I've made it out of steel. So now let's go ahead and make that out of steel. Now I can transfer this onto steel.
I feel nauseous, believe me. Never had a lot of shit come easy. Had to work hard, struggle just to be me. Had to rise up just so they could see me. Did what I had to do just to feed me. And what was left over I put towards my dreaming. But the only thing in life that has meaning are the things you gotta work for, believe me. It's only worth it if you work for it. It's only worth it if you work for it. I won't stop till they hear me now. I won't stop till I wear the crown.
There's the part cut and ready for drilling. That's both these plates cut out. I've made the second one off camera. I've used exactly the same methods. I've made it flat instead of angled. I'm just going to use some spacers to fill them gaps. Now I can get these painted in well-free primer. That's both these plates done and ready to bolt on. First I'm going to start with this side. So that's the first side installed. I still need to make these spacers and put some bolts through there, but that's going to work really good. Now I can get this side fitted. That's the plates done. They're now ready for the seamless tube to be attached. When I mount this thing in the car, that's going to give it a nice solid mounting. I'm going to put some rubber bushings probably on this side somewhere, or maybe integrate them into this top plate. But that's a good starting point now. That really helps me do the next step. So it shouldn't be too long before I can get this thing properly mounted in there. So I'm really happy that's done. That's just one more step towards finishing this thing. A big project like this is just loads of little jobs, so hundreds of little jobs that I just need to tick off the list. If you want to support me further, join the memberships. It really does help. It makes a big difference. It helps me pay for things like grinding discs and cans of paint, as well as some of the camera gear that I need. Things like the microphones occasionally get damaged, and the lens for the camera is getting a bit scratched, so it just helps me maintain this whole channel and keep going with this stuff. It just takes a massive amount of work. I appreciate everyone that's joined the members and new members that I've gained recently. It really makes a big difference. I've got lots more really cool things planned. Here's some extras that I've got as well that you may have missed. As I mentioned in the last video, there's also going to be extra supports in the back of the car that work with these compression bars. So I'm going to have bars that link from these bolts here down to the chassis, and I'm also going to have bars at the back that sit inside the subframe that join down to where this pipe's going to attach. So there's going to be 4 more tension bars in the rear of the car to assist these upper compression bars. That'll really lock the rear of the car in. But then bars are also used to support the gearbox. So the gearbox can have sleds that can move along these bars so that I can slide the whole engine and gearbox back together and they're perfectly in line still. So the whole engine and gearbox is designed to slide back in this car for servicing. I'm trying to make everything really easy to get at. So if I need to get around the front and get to things, as well as the removable firewall, I can also slide the engine back if I need to remove the alternator or something big that requires a bit more space. So this does make some challenges for me. I need to plan everything so it can slide back. Like the linkage that links the gear shifter to the gearbox has to be flexible. So I'm going to use cables. I'm going to have them come in from the side of the car. So when the whole gearbox slides back, they can just move like this without affecting the actual linkage itself. So I've designed the linkage in cardboard. We're going to be making that in a different episode. And then I'm going to be making the parts out of billet aluminium once I'm happy with the final layout. If you've made it to the end, double check you subscribe so you don't miss an episode. I'm working really hard to keep putting these out and to keep making good progress on the build.